Thanks so much to Saltmarsh Media for having me here today, and it's a pleasure to be back in Mumbai and certainly in India. I've worked on several data center projects in India over the 10 or 15 years that I've been working on data center projects around the globe. And I've been fortunate enough to not only work on projects here in India, but in about 25 countries or so. And I've been also very lucky to work with quite a few industry veterans or stalwarts out there as far as the companies go. Oracle, Google, Yahoo, Facebook, Equinix, Exodus Communications, Sun Microsystems, and quite a few others as well. So I've been very fortunate to have developed data centers for a lot of these companies and worked on energy efficiency programs and projects for them, as well as site selections and a variety of other things. And so consequently, what I'm going to do is I'm going to bring to you just some of the kind of initial thoughts that I have about what really makes a data center energy efficient. I've been working on making data centers energy efficient for probably, let's see, since I've really been in the data center industry, 15 years or so. Do you want to change this, or is it? Okay. For all of us. So in working with all these different projects and improving the energy efficiency over 12 to 15 years in a lot of very large data centers, I've learned a variety of things, and what I'm going to do is I'm just going to share some of those ideas and where I think the industry is going. So with that, let's just talk about energy really quickly and just sort of set the stage as to why energy and energy efficiency is important in our data centers. The reality is, all these companies I worked for, none of them did it because it was an environmental thing to do. That wasn't the primary reason. It may seem like that. The number one reason is because it's green, and what I mean is green to the wallet. Right? And of course in the US our money is green, so you can kind of understand that correlation. It's all about saving money. Roughly speaking, all the data center projects I've worked on, about 80% of the cost in building the data center is related to power capacity. So obviously if we can reduce the total power that we need, we therefore reduce our total cost in building a data center. And another kind of interesting statistic, I'm sure you all know these stats, but I just want to sort of set the stage, is that the server actually costs more money to operate than it does to buy. And this is true for all those companies that I've worked for many years now. So we spend more money on the energy to operate those servers than we actually do buying them. And so that kind of changes the paradigm as to really how it shapes our decisions about what we buy and how we buy it. And this has been partly driven, of course, by power density increasing. And of course the power density is increased because of the IT load, and the IT load continues to grow. 15 years ago when I first got in the data center industry, we were designing data centers about 10 watts a square foot. Traditionally today, 250 watts a square foot, or call it about 25 watts a square meter, is about where most data centers are being built. Many of the ones that I work on are closer to about 50 watts per meter. So fairly dense compared to certainly where we were 10 years ago, certainly much less than that. Now it does seem like power density is finally leveling off, which is interesting. I'll talk about some of the reasons for that and really where I think things are going with the IT load. But nonetheless, even though power density is leveling off, still the use of power, the energy consumed over a 10-year or 15-year net present value, the life of that data center, energy will be the largest cost other than the cost of servers themselves. And of course, the cost of servers themselves add up to be more because we're replacing them about every 2 to 3 years. And I'll talk about those refresh rates in a little bit as well in my talk. But today, still across the industry, meaning the data center industry, most of the energy consumed by the servers is wasted. Meaning, I'm not so much talking about the inefficiencies in the servers themselves, although I am talking about that, but I'm actually talking about just what the servers are doing. Most of what they're doing is completely useless computations. Useless meaning it's not driving to actually what we're trying to solve, what we actually ask that server to do. It's spending a lot of time just really waiting for data to come to it. So one of the things that we do is try to make sure that data gets to those servers immediately, as fast as possible, because we find that is generally speaking our bottleneck in almost all cases in IT load. And of course today we have very much a changing marketplace. If you asked me 5 years ago who Facebook was, or Zynga, or Twitter, I would not be able to tell you. And even a gentleman I worked with at Yahoo, he went to go work for Facebook, running their data center operations. And at a time when there were 20 million users, nobody really had heard of Facebook yet. We don't know what's coming down the pike as far as the next big company or the next thing on the web, social marketing, whatever it's going to be. We also don't know what the next iPad is going to be, or the next iPhone, or whatever that device is going to be. The bottom line is more of us now connect to the internet and more regularly with our mobile devices than we do with a desktop or some other sort of standing device. And this is, of course, a change that we've all seen. It changes how we operate and what we do in our data centers. And another thing, too, is that utility costs have continued been rising. And I know this varies all different parts of the world, but nonetheless, in all parts of the world I've looked at, and I've looked at about 50 to 60 countries to put data centers, energy costs continue to go up year over year over year, and sometimes fairly significantly. We have some utilities in the United States where utility costs are going up on average 10% per year. Well, at that rate, every 7 years, we'll double the cost of electricity. And I know those trends are also common here in India and as well as other places throughout Southeast Asia. So what this means is that energy costs, because they're going up, is only going to make energy even that much more important, and therefore making efficiency all that much more important in our data centers. So the bottom line is, yes, energy efficiency saves money. It saves it today. It's going to save it down the road. And the key thing is down the road, because you're not building your data center to last until tomorrow. You're building your data center, or you're retrofitting your data center, or you're installing servers in there in hopes that they'll provide you some operational uptime, some workload back over many years in the future. And most likely it's going to be 5, 10, 15, even 20 years. So we don't have to think about it that way. Now, most of the data centers I've worked on, first of all, let me ask the question. I assume everybody knows what PUE is, but just in case, it's power usage effectiveness. It's really what we use to monitor, of course, the inefficiency of the infrastructure of a data center. One being the IT load, everything above being the infrastructure, cooling, electrical systems, those losses, and so on. And generally speaking, in the U.S., our average PUE is about 1.7, 1.8. So it's still fairly high, but much better than it was. In the rest of the world, a few years ago, average PUEs were about 2.5 to 3.0. Now, of course, those numbers are coming down. But all the projects that I work on, whether it's, has been projects with Facebook or Google or Yahoo, and if you look at their data centers, you can certainly find out quite a bit of information online about them, about those data centers. All of those PUEs, generally speaking, for any new data center that those companies build today, has a PUE of about 1.1 or less. The average PUE of projects I've worked on over the last 3 years has been about 1.07. And so again, that's 1.07. So that means 7% of the IT load is going to cooling and electrical losses and lighting and all those other things, office space within that data center. So it's pretty trivial. So really what that says now is we got to stop focusing on the infrastructure. We have to really focus on the IT load, because that by far is where the vast majority of the improvements can be made. But the interesting thing kind of really about this is that all those companies, we used to always think, right, as an industry, that being more energy efficient meant costing us more either up front or somewhere else down the road in retrofits. It's not the case. In all of these data center projects I've worked on, our average cost to build are significantly less, usually about a half to a third less than what the standard industry data centers are. So we spend less up front and we spend less down the road. So it's an interesting concept, right? They're exactly correlated. So basically, people used to think that energy efficiency costs more money. It does not. And of course, it doesn't if you do it right. And that's the key thing. And there's some really key tenets of this, and I'll spell out a few of them, right? One is, not only do we have to look at efficiency as far as the capital front, but of course down the road, as I mentioned, but also efficiency is speed, right? It's time to build. It's time to develop. It's time to code, some new application. It's time to replace the servers. All of these things. The more we speed up the process of everything that we do in our data centers, the actually more energy efficient it becomes, the more cost efficient. So therefore, the more money we save, the more time we save, the more our data center now meets our needs today, and better actually meets our needs down the road. And that's one of the key things as well to efficiency, is making sure we're not just meeting the needs of today, but also down that road. So we save in all these different things. And of course, adaptability is one of those key things to adjusting the data center to meet our needs down the road, because we don't know how IT is going to change. And I'll talk about some of those things here shortly. One of the key things that we did at Yahoo is really to improve our efficiency was look at everything holistically. And what that means is that the people actually developing the code for our operating systems and our applications in our data center, the people buying the servers, the people making our capacity planning for our data centers, the people managing the data center operations, people developing the data centers, designing, building them, and so on. Everybody in our networking team and many others all sat in a meeting every single day together. And they shared all the challenges and problems and worked through them together as a team. They all managed and reported to the same people, right? Meaning the same person. They also all managed and reported on the same metrics. And the key there is that everybody was working together. So we thought about not just our data center as one little simple slice and say, okay, I can make the servers more efficient, I can make the code more efficient, I can make the data center more efficient, I can make the network more efficient. No, let's make it all work together. Because you don't want to get efficiencies in one area that hurt another. And so the key is we're looking at it holistically, making sure you're looking at every piece of the data center together all at once. That no single decision is being made without the whole entire data center's efficiency being thought of. And I say efficiency again, meaning money, time, and all the other things that go into efficiency. So those are some key things. Another thing is really drive to metrics. A great example is Microsoft, a very large company that we're all familiar with. Every single employee in that company can look at their data center metrics in real time. All right? They don't hide it. Let everybody make the decisions based on what's going on in their data center. eBay's broken it down because they have a simple business model to one metric, right? And that's watts per transaction. And basically everybody that makes decisions about the data center makes decisions based on that. Google, it was, watts per search query or other things like that. Yahoo is watts per page delivered. So it's a very simple metric. Everybody aligns to that. Everybody helps to drive that efficiency down or improve that efficiency and drive that cost down and drive that metric down. So some things to kind of think about as far as data center efficiency goes. One is reliability. I've been in this area long enough time to see that we have essentially over-provisioned when it comes to reliability. And what I kind of mean by that is we don't want to think about all of our servers in one data center, right? That's how we used to do things. And nowadays, I assume that most companies are certainly not that way. We want to, make sure our data centers are geographically diverse to each other, right? That's really the most important thing. Because basically, as far as an outage goes, right, 2 low reliability, meaning say tier 2 or tier 3 data centers, are far more reliable so long as they're geographically diverse than 1 tier 4 data center. Far more reliable, right? And part of the reason why is because you don't know what kind of natural disaster or human-caused event is going to take down a data center in one area. So now what you do, instead of having this tier 4 data center, which has a lot of inefficiencies in it, because you have a lot of extra things running, generators and chillers and UPSs that really aren't there to support the load. They're really there for redundancy's sake. So they're not really adding to the value of that data center, except only during an outage. However, the way we've done things with Google and Yahoo and Facebook and others is make sure that all the applications are portable. They can all move around. And they can move around real time. And this happens all the time. Just this morning, I hopped on Yahoo, and all of a sudden, right, when I hop on Yahoo, all of a sudden, all of my information ports over to a data center here. Right? It's actually one not far from here. Instead of the one in the US where I'm normally connected to. It all happens in the real time in the background. And if the Mumbai data center went down, I would just simply get reported over to probably Chennai or one of the other ones that's nearby. Now granted, not everybody has the luxury of having multiple data centers in different geographies, but it's absolutely essential to really this reliability if you want to achieve the greatest reliability at the lowest cost and the highest efficiency. So much so that at basically Google and Yahoo, we started actually rethinking, do we even need UPSs, right? And the reason why we think that is because, well, the applications are redundant to each other in different geographies. If one data center happened to go down because of a utility event, which I know can be common in different parts of India, right? But also can be common in some parts of the US or other parts of the world. And if it does, all the applications so forth automatically just reroute somewhere else. It all happens in basically, a matter of milliseconds. It doesn't cause any issue for the users. So by doing that, we now can build these lower cost data centers and operate them at more efficiency. So we think, do we even need UPSs? Or we think, do we even need them for all of the load? A great example is at Google, there's only 1 tier 4 data center in the entire company. You know what it does? It manages the company's financials. And that's it. For the most part, nothing else is really tier 4. It doesn't need to be. Because of this redundancy in different geographies. You probably heard in the news about Facebook, of course, really debating if they even need any generators at their new data center that they're building right now in Sweden. And they will have some generators, but a very minimal amount. And a very minimal amount meaning just absolute minimum just to make sure that certain key systems stay up and running. And that's it. most of the IT load is not going to be connected to generators or to mechanical systems or the UPS systems or anything else. If it goes down, it goes down. And so in that instance, they rely on their other data centers, right? And they save a lot of money building it, and they save a lot of money down the road. It might seem kind of really far-fetched, but I can say just about everybody is going this route, right? Only saving the tier 4 or even tier 3 data centers for the more things that really absolutely need that reliability. And here's an interesting statistic, because we analyze this at Google, and we analyze it also in some other companies, is that over 90% of all the outages in a data center occur because people make a mistake. Right? Equipment will always fail. But we also found at Google that the more complex we made a data center, meaning the more reliability we put into it, the more likely people made a mistake causing it to fail. So even though statistically, and you look at it and you say, okay, it's going to be more reliable because you have more equipment in there, and so therefore the chance of one piece of equipment failing and causing the whole data center to go down is very slim. The actual chances are now that more people will likely mess it up when there is an outage. So don't think about it complex. Think about it very simple. I'm under NDA with a lot of companies. I'll just say there's a very well-known big company out there in the technology space I'm working with right now on their data center project. And they're also rethinking, do they even need generators or UPSs or any of that stuff? And they're also really focused on this simplicity. Make the data center as simple as it possibly can be. So this way, we as humans, when we operate these data centers, don't make a mistake when something happens. And having run data center operations years ago, I know very much what it's like when you run into a data center in the middle of the night and you're trying to fix things that basically have failed. It's very stressful and it's difficult to get it right. Another thing is really adaptability in our data centers. And all the folks I'm working with, we really focus on this adaptability. And you can think about this scalable or modular. There's a lot of different buzzwords that we think about. But the bottom line is we really want to make sure that it is adaptable, that if we need to add an application feature, it needs more reliability. It can be fairly easily done. If we need to add power density or even take away power density, it can be fairly easily done. If we need to add power capacity, it can be easily done. And so this way we're not stuck to a certain architecture. I learned this mistake about 5 years ago building a data center. We just recently designed it and just built the first phase for Yahoo. And we built that first phase, but it was the first phase of 9 phases over 3 buildings. And so there's 3 phases per building. We already built the building. By the time we finished just installing the first phase, and each phase is pretty sizable, say about in the 5 to 10 megawatts of IT load per phase. Once we finish that first phase, which only takes us a few months to install it, of all the IT load, we are already out of date. Meaning that we already wanted to do the cooling system differently than we need to. We already wanted to do the reliability or the electrical power systems differently. And we already wanted to do the density different than we already built it to. And now we are constrained to this existing building. So we learned, make the buildings very small, modular, cheap, efficient, and that way they can easily be replaced, they can easily be retrofitted, and they're smaller, so we're not building on these big building blocks like we used to do. All right? And that way we're always adapting over time. So these are key things. We don't think about it just in the infrastructure, but also on the IT side, all the software and all the hardware. Make it very adaptable. One of the key challenges you went through at Google and Yahoo and Facebook's going through the same thing right now is that the application really wasn't written to be geographically diverse in all these different locations. And partly because when the company started, it was just one little data center and that was it. And as the companies grew and their number of data centers grew into the tens or even hundreds, it became very difficult to manage the applications. The whole application had to be rewritten. So a lot of these companies even think about that as you go along and make sure it's written well and supports all your needs. Another key thing to think about too is really the environmentals in the data center. And this I know is a challenge in relatively hot and humid areas like here in Mumbai, where you do get a lot of condensation if you run these higher temperatures or if you let the humidity branch out. But at different locations in the US, we actually have no humidity controls. And this was really driven by Intel, of all people. Intel actually did a lot of studies, and I worked with them on some of these studies about 5, 6 years ago, where they ran data centers with no humidity controls and no environmental controls. And what they found is that servers really didn't fail because of temperature or humidity, because of the number. They only failed because really of dramatic humidity changes, meaning going from 10% to 90% within 1 hour. And that was it. And the failure rate was so trivial that it was hardly even accountable for. And Microsoft did some similar studies. We did similar things at Google where we played around with the temperatures quite a bit. We saw no increased failure rate. And even if there was any increased failure rate, it was so trivial that we couldn't really account for it statistically. And And so we just said, heck, let's push these limits. And the limits, of course, are what's really humanly comfortable. Because Intel themselves will tell you that specifications on their chips is about 140 degrees centigrade, right? So it's not so much that the equipment can't run at these higher temperatures, it can. And today, all equipment generally can run at 40 degrees C. We know that as far as inlet temperatures, and we've accepted that as an industry. So think about that. And so really think about broadening your humidity ranges. We don't need 40 to 60%. The server's not going to run any better. Even if it rains in that server, it'll likely still run, right? And I know that sounds really crazy, but I've had data centers for Oracle and for Microsoft projects that I've been involved with some of the discussions where it has rained on those servers. And here's even a picture of one in the upper left of your screen, or upper right, in that server actually ran outside under a tent. The tent leaked, it sucked in leaves, the tent actually blew down, rain rained on it, and it still kept running. We've done similar tests as well, and things kept running quite well. So we push these temperature envelopes. Microsoft, a good example, runs their data center inlet temperature at 95 degrees Fahrenheit, up to 95 degrees Fahrenheit wherever they can. Google's about the same. Facebook is pushing 85. Many of the people are, and that's again 85 Fahrenheit. So about 35 to 38 degrees, you know, and sometimes as much as 42 or 43 degrees C. So very, very hot temperatures. One of the things that we do is generally speaking, we don't have tape in our data centers. Tape's a little more temperamental as far as temperature, humidity, and even particulates go. So we generally do try to run tape in a different location if we have it. This is pretty rare in these kinds of data centers I work on. But if we do, it's usually in a different room with different humidity and temperature controls. So we're not trying to, meet the needs of the tape with all the servers. So these are a few of the things to think about. As far as kind of the essentials of good design, I'm going to go through these pretty quick because I'll talk about these in more detail in my workshop later today, near the end of the conference. But I'll just run through them pretty quickly. One is, of course, always work within the laws of physics. The basic one is the cube law. Reduce that fan speed, dramatic effect. In every single data center we retrofitted, whether it's crawl units or crack units, we always install VFDs on those crawl or crack units. And every single time we do it, we always drop down to the minimum speed that we set for those VFDs and those fans. And we still meet temperature perfectly fine. The only drawback is it's quieter in the data center. What a terrible drawback. Imagine that, a quieter data center. We save tons of energy. Obviously going from 100% to 80% fan speed is a 50% reduction in that fan's energy. Dramatic changes. Simple little things that we can do. Every crawl and crack unit is capable of handling a VFD. There's always over-provisioning there. It's amazing what the effects can be. We've also done fanless hardware. At Google, this is what we've done. There's some pictures of this on the internet. We basically, build our own servers. They have no fans in them at all. We don't need them. They're not needed at all. We don't need to extract that heat. It's amazing how much the servers that we buy from Dell or HP or others, not to put them down, but in the past we used to have some pretty rougher conditions. The fans that are on those servers are always over-provisioned. And so hence why they speed up and down, of course, as they need to. At Yahoo, we did the opposite. We did what we call fanless data centers. No fans in the data center at all, only fans on the servers. And of course, these are, again, custom-built servers, so we designed the fans to only draw through. Typically speaking, most servers have 3 times the fan energy necessary to pull air through them than what is necessary. So a dramatic difference. We always, of course, closely couple the loads. And this, of course, means hot and cold out containment and other things. Sometimes we design strategies that are patented, so I can't get into some of the details, where basically the heat exchanger that exchanges heat with the IT gear is extremely close to the IT gear, as close as possible. So think of it as like a rear door heat exchanger or like having a heat exchanger on the chip itself. That way we have very little energy waste with just pushing air around, as we all know is very inefficient. And of course we do as much accommodation as possible. Most of the data centers I work on today, as a matter of fact, I haven't worked on a data center in 2 years that has a chiller. No compressors, no chillers, nothing, no DX. They're all economized, whether it's air or water. Now granted, climate, allows you to do this in some locations and not so much in others. But because of these higher or broader temperature and humidity ranges that we can use on this IT equipment, we really don't need chillers or compressors in most locations of the world. We're doing this even in locations where temperatures exceed 50 degrees C, outdoor temperatures. and we still are economizing 100% a year. There's ways to do this, right? And that's the secret sauce that I get into as far as efficiency, but it's very doable. Saves you a lot of money up front, saves you a lot of operating expense, saves you space, saves you a lot of other things. On the electrical system, key things here is getting rid of transformers. We do this in all the data centers we work on. We deliver at high voltage. In the US, it's 480 volt. In most of Europe and Asia, we use 400 volt right to the rack. And we do that right out to the rack. And if you go to, of course, Facebook's Open Compute, you'll see some examples of this. I won't get into details right now. We usually, if we do use UPSs, they're either rotary or flywheel UPSs, or they're, of course, an offline UPS. We generally don't use any sort of a delta or dual conversion, just way too inefficient. And there's no need for it. You don't gain any more reliability with those UPSs. At least we've not seen it anywhere in the projects I've worked on. We always do, of course, all of our mechanical and electrical distribution overhead, and there's efficiency benefits for that from a mechanical standpoint, as well as even from a cost and just building out. And of course, we always meter everything. One project for eBay had over 600,000 points metered in their data center. 600,000, right? It's hard to manage that, but we can't, there's our software systems out there that can manage it very well and give you really good data back. By metering all that stuff, we know exactly what's going on, where to save, where not, and what benefit we're getting back when we make changes. Software, of course, I'm going to talk about some of the basics. We all know about virtualization. Typically people are getting anywhere from 10 to 1 or even as much as 100 to 1 ratios, right? Virtualization is not the holy grail. The majority of savings in virtualization are because we have servers running that don't need to be running, right? And we end up shutting those down through the process of virtualizing. So it's not virtualizing itself, the virtualization software itself, that saves us most of the money. It's just looking at our servers and realizing there's a bunch out there that don't need to be running physically, and we've been virtualizing them, right? So the big thing here is making sure you turn servers off. Don't leave servers running that don't need to be running. If they aren't doing anything, turn them off. Believe it or not, Google does this all the time. They're constantly turning servers on and off. There's no need to leave those on if they aren't doing anything. Make sure you focus on capacity planning, so design the data center to meet your exact needs, right? And of course, there's software like 1E and PowerShare which will automatically put servers to sleep, right, or shut them off when they're not needed. Automatically turn them back on. A lot of large companies are already doing this. They do it in-house with their custom solutions. Facebook's an example of that. And others, of course, buy these solutions to do that. And really focus, of course, on only keeping what you need, and again, the monitoring, that controls, the DCIM software, really look at everything out there. Hardware is an interesting place where a lot of changes are happening today in the data center market. And a good example is, really, I'll just come out and say it right up front, because I think it's one of the most interesting things, is ARM processor-based servers. We're already testing them out. HP's already connecting up with Calxeda to sell. Calxeda is a manufacturer of these ARM processor-based servers. Dramatic differences. We're getting about 1,500 servers into one 8-kilowatt rack. And the amazing thing, really, is not so much we're getting the equivalent of 1,500 servers in that same 8 kW rack, but that we can actually run the entire rack on just 5 watts. So when all those servers aren't needed, they just all shut off, and they can turn back on in microseconds. So this is, again, back to the point that your demand changes all the time in the data center. It's always variable, right? And so by these ARM processor servers, we can turn that load up and down, meaning the actual load, unlike, of course, a traditional server, which is nowhere near that. We always focus on the slowest processor possible when we go out and buy servers, almost in all cases, for Microsoft, Google, Yahoo, eBay, Facebook. In almost all cases, they buy the slowest processor possible. They generally don't need more processing power. The limitations are really in the I/O, getting that storage data to the servers. And of course, memory helps a lot with that too. So always the most memory possible, the slowest processor speed that saves a little bit of energy, saves some money, and always focus on solid state drives as much as possible. At Yahoo, our trick was always put some small little solid state drives right onto the board that handled all the OS and the applications, and everything else just went off-board storage that was much faster and cheaper. So there's a lot of things. Also, there's much more efficient power supplies out there than what typically is bought. All the big manufacturers, whether it's IBM, HP, Dell, all offer it, a more efficient power supply. The savings generally go from about, instead of a 20% loss on the power supply, go up to about as little as about a 5% loss. Huge difference, very little expense spent. And of course, Energy Star is a great way to make sure you're getting a more efficient piece of hardware. I talked about, of course, storage and data deduplications like the virtualization of the storage side. We see dramatic benefits by doing that. Also, this graph that you might be able to see that's up in the upper right really shows some benefits of anti-vibration. And a lot of the data centers I've been in, especially here in India, vibrate a lot from the mechanical equipment. That causes a much slower throughput on the storage, which of course slows your whole system down. Now you need to over-provision not just servers, but also storage, and just to handle that speed. So by making sure we're not basically over-provisioning, speed things up, anti-vibration racks is an interesting thing to do. And there's a lot of other things too. I talked about refresh rates. Most of the companies I work with, the refresh rates are 18 months up to 36 months. So much, much faster than what we typically did, because we actually find it's economic to do so. It's cheaper to replace that server sooner than it is to hold on to it, because it's costing us so much money and energy that it's cheaper just to go buy a new server that's much more energy efficient, replace several old servers with that one new one, because it gives us so much more compute capacity. So there's some key things. I'm just going to wrap up here in the next couple of slides. Few key things. Obviously, I talked about modularity, scalability. Raised floors generally are out, at least in all the data centers I work on. It's actually not only cheaper, but more energy efficient to not use a raised floor. And we go to wireless sensors. It's also cheaper to use wireless sensors, and we gain some efficiency benefits. So for the most part, in conclusion, I think I talked about, all these things, but really think about containing the hot and cold air streams, keeping them separate, using variable speed fans whenever you can, wherever you can. You will gain benefits from those. And every single example we've worked on around the globe, hundreds of them, we always have significant savings. Obviously, make sure you measure and report as much as you can to everybody on your team about how you're using energy in data center, so everybody can make good decisions about it. And again, think about the whole entire data center holistically, not just as one little individual components or little parts. We wouldn't think about buying a server as just one component. Say, oh, that DIMM of memory is really good. I'm going to buy a whole server because that DIMM of memory is a really good, DIMM of memory. No, we're going to think about the whole entire server. Same with the whole entire data center. Same with the software. So, and again, focusing on really what the precise needs are of the business as far as capacity, reliability. Not every application needs high reliability. Not every application has the same densities, et cetera, et cetera. Match those to what the needs are. And always make your decisions based on total cost of ownership over time, because then good decisions get made. So some of the key items, again, broaden temperature and humidity as much as you possibly feel comfortable. And say you feel comfortable, meaning you as a person, right? Not the equipment. The equipment is generally always going to be good. Unless it's raining in there, you'll probably be okay. And of course, there's a lot of other things you can do, but one of the key parts is also never forget that off button on the servers. They all have them. They're designed to handle 8,000 on and off button switches over their life, more than we'll ever do. You can turn those servers off. You can put them to sleep. Don't let them run when they're not doing anything. Much of the time they are. So with that, I want to certainly thank you so much for having me out and your attention. And I'll be around throughout the day for answering any questions, or also here's my email. Feel free to reach out to me if you'd like to. Thank you.